the amplitude. Now you know that this, when you expand using trigonometric identity, sine of theta plus or minus pi by 2 will be cos of theta. So sine of kx minus omega t minus pi by 2 is cos kx minus omega t. So the equation for the harmonic sound waves in terms of the pressure variations is Pxt equal to P0 cos kx minus omega t, where P0 is the pressure amplitude. And now you can see the same situation we have seen before. Kx minus omega t is the same as k times x minus vt. You understand that? Where k is the wave number and v is the speed of the wave. Now in the equation p equal to p0 cos kx minus omega t, omega is the angular frequency that is equal to 2 pi f. And you know that these two equations are the same. We have dealt with this several times before. The pressure amplitude P0 is given in terms of the displacement amplitude S0. Remember, we expressed this equation using the pressure. We adapted the equation from displacement. And so, you must be familiar with a relation connecting pressure amplitude P0 and the displacement amplitude S0. It's an important relation. It is P0 equal to rho omega V S0. Rho is the density of the medium. Omega is the angular frequency, that is 2 pi f. V is the speed of the wave. S0 is the displacement amplitude. P0 is the pressure amplitude. So a relation between pressure amplitude and displacement amplitude. Okay, let's do an example. A sound wave in air produces a pressure variation given by Pxt equal to 0.75 cos pi by 2 times x minus 340 t. Now, can you tell me what form is this equation? Well, this is of the form Pxt equal to P0 cos k times x minus vt form. Is that right? So your k is pi by 2. V is 340, that's the speed of the wave. So, where P is in pascals, the pressure is measured in pascals. X is in meters, T is in second. Find the pressure amplitude of the sound wave. Well, there's nothing there to find, it is there. This is the pressure amplitude of the sound wave. The wavelength lambda is contained in K. Remember K. K is 2 pi divided by lambda. And you know K equal to pi by 2. The speed of the wave, again there's nothing to find the speed. The speed is this, x minus vt. So that is your speed. And the frequency. Well, if you know your speed and wavelength, then you can find the frequency. So these problems are very simple for you. Let's put these things together. Compare the given wave function with the general form Pxt equal to P0 cos k times x minus vt. This is the general form of this. So, you got P0 is 0.75, K is pi by 2, V is 340. Pressure amplitude is 0.75 Pascal. The value of K in this expression is pi by 2. but k equal to 2 pi divided by lambda. So we say 2 pi divided by lambda equal to pi by 2. Can you solve for lambda from here? Well, I can tell you from one look, pi and pi cancels, lambda equal to 4 meter. So we obtain the wavelength. Alright? What is the speed of the wave? The speed of the wave is 340 meter per second. Well, and finally the frequency. Frequency F equal to V over lambda. We know V is 340 meter per second. Lambda is 4 meter. Therefore, the frequency is 85 Hertz. Alright, so that means once you know the harmonic wave equation, you have practically all the information about that wave in that equation. Alright, let's do another problem. Example 4. What is the displacement of a sound wave having a frequency of 100 Hertz and a pressure amplitude of 10 to the power of -4 atmosphere? Well, you know there is a relationship between pressure amplitude and displacement amplitude. And part B, the displacement amplitude of a sound wave of frequency 300 Hertz is 10 to the power of -7 meter. What is its pressure amplitude? Alright, so both these are using the relation between pressure amplitude and displacement amplitude. Well, I don't think you remember that equation I gave you. Let's pick the data. Pressure amplitude in part A. Pressure amplitude is 10 to the -4 atmosphere, which when converted to Pascal, remember, atmosphere can be converted to Pascal by multiplying by this. This is 1 atmosphere in Pascal. So we know we have P0, we have the frequency 100 Hertz, we have the speed as 340 meter per second. And this is the relation between pressure amplitude and displacement amplitude. We need to find the displacement amplitude. So we need to solve for S0. S0 is P0 divided by rho omega V. And we know all those values, don't we? Now, P0 we know, this is P0. Rho, the density of air, you remember I gave it to you, 1.29 kilogram per meter cube. Omega is 2 pi F, where F is given to us. V, the speed is 340 meter per second. So, put all those values and calculate S0. It gives me 3.67 times 10 to the -5 meter. And that is the displacement amplitude of this wave. Okay, let's do now B. In B, you are given the displacement amplitude. You are given the displacement amplitude. You need to find the pressure amplitude. So, we go directly to the equation. Pressure amplitude is rho omega V S0. We know all these values. Rho is 1.29 kilogram per meter cube. Omega is 2 pi times the frequency. Frequency is 100 Hertz. So that will be 2 pi times the frequency. Isn't the frequency 100? Well, V is 340 and S0 is 10 to the power of -7. So I think this 300 must read 100. Is that right? Yes. So we must change that for you. That will be the pressure amplitude equal to 8.27 times 10 to the -7 Pascal. Okay? Let's now talk about another concept of sound. intensity and intensity level of sound waves. What is the meaning of intensity? How intense is the sound? Now remember, sound wave is generated by a vibrating object. That means a vibrating object has a certain amount of energy, right? So this object gives out a certain amount of energy. Intensity is measured in terms of the amount of energy that passed through a certain region. Suppose I want to find the intensity of this sound where I am standing. Now, the intensity of the sound where I am standing is a measure of the energy from here that passed through a point where I am standing. Okay, we have to make it a little more concrete, the definition of intensity of sound waves. And then we will distinguish between intensity and intensity level. Alright, so pay attention to this. A vibrating object sends out energy in all directions. The amount of energy emitted by the vibrator in 1 second is called the power emitted by the source of sound. Now, most of you know that you talk about the power of your loudspeaker, don't you? What does it mean when you say your loudspeaker has a power of 300 watts? A watt is joules per second, energy given out per second. In other words, the energy given out by that loudspeaker every second is 300 joules. That loudspeaker has a power of 300 watts. So the amount of energy emitted by the vibrator in 1 second is called the power emitted by that vibrator. The intensity of the sound at a point, a distance r from the source, is a measure of the power crossing at right angles to unit area containing that point. Now what does that mean? Suppose I take a unit area. What is a unit area? A unit area is an area of 1 meter square. Suppose this is the paper I crumbled some time ago. Suppose this is a unit area and I have an object vibrating in front of me. Now I want to find the intensity of that sound at a point here. All I need to do is take a unit area containing that point and measure the total energy crossing at right angles to that unit area. You see, that is a measure of the intensity. So what is the intensity again? The intensity of a sound at a point is a measure of the energy, the amount of energy crossing at right angles to a unit area that contains that point. And we will represent intensity by I, and it is measured in watt per meter square. In other words, intensity at a point is a measure of the power that is crossing at right angles to a unit area that contains the point. Suppose I want to find the intensity of a particular sound, that is, the source is somewhere there. Now to find the intensity, what I do is I keep a unit area where I'm standing and measure the power crossing this unit area, and that will give me a measure of the intensity of that sound. The intensity level of a sound determines how loud the sound is. So look at this. They are not the same thing. The intensity of a sound is the power crossing unit area containing that point. Whereas intensity level is actually the loudness of the sound, how loud the sound is. Now, how loud the sound is depends on the amplitude